Welcome back to the channel. In this video, we're going to walk through how to run the AWS Flask and Celery app locally on our machine. We're going to do this using Docker Compose with Docker Desktop. Now in this video, I'm not going to walk through all the configurations and the application files as deeply as I did in the previous video, or as I've done in the previous video series, where in the local run, I go through all the files individually. I encapsulated it all into a video right before this. The reason being, the previous video series, there wasn't as many configuration files. For this video series, there's a lot. We have nginx, Flask, Celery, a lot more than usual. So I wanted to put it all in one individual video with timestamps so you can easily reference back if you want to understand a file in more depth as I'm going through it in this video or in the subsequent videos. So with that being said, let's go ahead and get into the video. If you didn't watch the last video, then you haven't actually cloned the repo yet. So you can easily do that. We're in the repo right here. Gonna go to code, copy to clipboard, open up your terminal, git clone, paste it, and then cd into the directory. Great. Also make sure you have Docker desktop running or some equivalent to where you can run the Docker Compose command on your machine. Now I'll step into the code and briefly go through what's happening through the code before we actually see it in action in our browser using Docker Compose. Before we get started though, real quick, help me out a lot. Sponsor me to GitHub sponsors right here or on Patreon, one time recurring, wherever you want. You can subscribe to the channel, liking this video, commenting, sharing on platforms you use like Reddit, LinkedIn, etc. And starting the repo right here on GitHub. And also follow me on GitHub. All these things help me out a lot, really appreciate it. And yeah, with that being said, let's get into the video. So open up the code, use your favorite code editor. I'm using Visual Studio Code, use whatever you want. First file we're going to look at is Docker Compose. It's in the top level directory. We already went through this in the last video, but real quick, we're running 6 different services. RabbitMQ or Redis, we're going to use these interchangeably. This is the message broker for Celery. Celery Worker is what we're going to actually use to run tasks asynchronously. Celery Flower, this is the dashboard where we can see all of our Celery Worker tasks running and having a little bit of an admin view of it. Celery Beat, we're going to use this to schedule Celery tasks to run at certain intervals. If you don't need this, no big deal. It's not really a big deal, but I'm giving you this functionality so you can use it if you do need it, or you may need it in the future. The Flask app itself as the interface, and nginx, which we're going to use as the entry point to our application. So we don't have to do localhost port 5000. We're just going to do localhost because nginx is going to be the only entry point for our application. Okay, next file real quick, your.env or your.env. This is all as is. You can leave it as is, no big deal. You may want to change this Flask secret key to something a little bit better. The only reason we even need this is just for the flash message. It's a little banner that pops up when we send an email. But you can leave it as is, not really a huge deal. Unless you go in production, you obviously want to change it. The big thing you need to set here though, the reason I'm going through this file is right here. This mail server, port, username, app, password. If you're using Gmail, no need to change this. If you're not, you need to change it. Port 587 is pretty universal. You may need to change it, probably not. Username, obviously put your own username right here. And then your mail app password. If you're using 2FA with your Gmail account, which is probably enforced by now anyway, you're going to have to use an app password. You can't just use your normal email password because you have 2FA and you can't access it programmatically when there's a 2FA code in the middle of that. So copy this URL right here, open up your browser, go ahead and paste it. You got to sign in. And once you sign in, you'll see your app passwords right here. I made one right here called AWS Flask Celery. And then you can just create your own right here. So let's call it test, create. And this is your app password. So you click done, you go back. So right here, you can highlight it and paste. And then just remove the spaces in between. And then you're all set. Obviously, I'm not going to keep this because I just exposed it, which will give it programmatic access to my email. So I'm just going to delete this real quick. Great. So I'm all set there. Now, once you have that set, you should be all set too. Next, let's quickly look at the Dockerfile. We're using this for our base Dockerfile image for the Flask app, the Celery Worker, and the Celery Beat. They're all using the same Dockerfile. We're using pyproject.toml. This is just an alternative to requirements.txt. Again, I went through it in more detail in the previous video, we're installing our requirements, and then we're setting this my user from right here. We're the same one we added. This is just standard security practice. And then we're changing the mod to 755 for the app directory, which is going to host our application files for the Flask app and also our Celery files and configurations. Great. We have the Dockerfile for nginx. This is just so we can run nginx with configuration, have as entry point for application. You can walk through this more in detail or refer back to the previous video. App.py. This is our Flask main file, the app.py. We're calling this create app from the init.py file. And we just have a few routes here. The big route I wanted to highlight right here, the one we're going to be seeing in this video, is this send email route. This is one of the very big use cases of Celery. When you ever want to do asynchronous task, a big one that comes up is email. When you click send email, instead of waiting for the email server to respond, the email has actually been sent and delivered, meaning that the application hangs, the user can't interact with it anymore. It will automatically process it, send it to the message broker with the Celery, so then that the user can keep interacting with the application and you don't have to wait for a response from the email server. It's one of the primary use cases, and that's where we're going to see it here. We have a simple index.html. It's going to show a simple form. You input these three values, recipient, subject, and body, and then you call this send async email.delay. Send async email is coming from the task file, which is where you have all your Celery task. Where a Celery task is a function with Celery that you can run asynchronously. And you call the Celery asynchronous task by the function name followed by delay. And we pass in our values. We do this little flash message. Remember that I said before, you need that for the Flask secret key. You have to specify that to have this flash message actually work. And then we turn the redirect. And immediately the user is able to interact with the application again. It doesn't have any kind of hang or waiting. It immediately becomes available. Going on, nginx configuration. Now, I said this in the previous video, and I'll reiterate it here. When I was first learning nginx and I saw files like this, I became very discouraged. This is very different than what I'm used to seeing with programmatic languages like C++, Java, Python. It's much, much different and seemed very esoteric. But the nice part of this is there's a lot of just comments up here. And you don't even need these lines right here. These are only really needed in a production sense. We want to retain information about the original client's IP. Really, you just need to understand there's 1024 worker connections. This is just standard practice. Don't really need to understand that much. Here's the server. We're listening on port 80. All this means is that we can access localhost without specifying port 5000 or 555 for Celery Flower dashboard. We just do localhost port 80, where 80 is the default port, so we can just do localhost. This allows us to have an entry point for our application so we can access everything else. And the way we do that is we specify the subdirectories or the subpaths of the localhost. At the root directory, we're sending all traffic with this proxy pass to our Flask app on port 5000. Back to docker-compose real fast. Here's Celery Flask app, port 5000, exposing port 5000. Great. And then the same thing with Flower. So subdirectory Flower, subpath Flower, we're actually accessing the Celery Flower application on port 555. And just like in Docker Compose, Celery Flower container is exposing port 555. And again, not necessary, good practice. Don't really need to understand it. Don't get bogged down. And last, this is just allowing us to load the CSS JavaScript files using nginx rather than from the web server directly. Increases load time. It's again, nice to have. Don't be bogged down. And here's our Celery app.py. This is where we're specifying our Celery configurations, our Celery broker URL. We're using Redis rather than rabbitmq. Going back, we can use rabbitmq or we can use Redis. We'll change it later on in the video when we're actually running it. We set our Celery backend. Use the same broker URL if we're using Redis. Otherwise, you use rpc:// for rabbitmq. We initialize our Celery app. Great. We include this project.task, which is our Celery task. We'll see that in a second. This is just optional, nice to have. You can use multiple queues with Celery. I didn't actually create this. I just provide boilerplate code so you can do it if you want to. We set our Celery app config update. This just means that Celery task will expire in the Celery Flower dashboard, meaning they're no longer accessible after a certain amount of time. We specify that here. You can change that if you want. And then the Celery app config beat schedule. We're specifying one of the Celery tasks at every 10 seconds to run on a schedule of every 10 seconds. This is again just boilerplate code. You don't need to have this. It's just a nice to have. And it also gives you a starting point if you want to have scheduled task with Celery beat. And we just set the time zone. Great. The last file we're going to go through is the tasks.py. Let's go up to the top. All the tasks.py has is just a bunch of Celery tasks that we can run asynchronously. This test print right here, this is the function that we were running with Celery beat. Go back to Celery app, we're calling project.task.testprint. And we see this is underneath the project task.py. So it's underneath the project directory. Scrolling down, the big one that we want to look at for this video is the send async email. This is the function we're calling asynchronously with our Celery worker to send the email so we don't hang up the application. Go back to app.py, send async email.delay. That's where we're getting it from. This is where we're importing the send async email function. Great. So that's a little quick overview of the files. Again, if you want to see the files in more depth, understand more about what's going on, refer back to the previous video. Okay, with that being said, open up your terminal again, go to the same directory where you cloned it, and make sure you have Docker desktop running. Again, I said in the beginning, I'll say it again. If you don't, this command will not run. And then we're just going to run docker-compose up -- build. Let that run. Okay, after giving it a little bit of time, you should see everything running. Celery Flower is not going to be able to connect in the beginning. It's going to need a little bit of time for the Celery worker to finish starting up, and then Celery Flower will be able to connect to rabbitmq correctly. After that's done, and you see everything is running fine, you see these test prints happening every so often, then you know you can access your application. So we'll go to our browser, and let's go to localhost, and no port required, because again, nginx, port 80 by default, then we don't need to put port 80. We can do port 8 if we want to. That's the exact same thing. Great. Next, let's actually see the send email function, the big one that we have in the app.py. And we also specify in the Celery app file for the project.task. Okay, so recipient, that's my own email right there. I'll put the subject, put test, and test body. I'm going to send this email. Great. Now if we scroll down, we'll see this little flash message right here, sending email. The application didn't hang. It didn't get interrupted. Zoom out a little bit. We didn't have to wait for this email server to respond back to us saying the email is delivered. There was no spinning wheel waiting for it to finish processing. We immediately got a response back saying it's sending the email now. Not sent, but sending, meaning the Celery worker is doing it. So the user knows the email sent is being happening, but it hasn't completed just yet. Now we can verify the email sent by going to our inbox, and we see right here, to me, test body. Great. So we know that it worked. Minimize this. Now, the other thing I wanted to show you is the Flower dashboard. Now remember, we access it by just Flower. How do we do that? nginx.config, location, Flower. Proxy pass, which is directing all traffic to our Celery Flower application, running on port 5555. So we go here, we see we've had 15 events processed by this Celery worker. Give it a quick refresh, and you'll be able to see it. Our broker, our queue, our task. We see 2 tasks that are running. Our send async email, we ran it 1 time. Our test print, which is running every 10 seconds, as specified in our Celery app, right here, every 10 seconds, we see it's ran 15 times so far. Now, one other thing I wanted to show you real quick. Now, this is just an nginx thing, so feel free to skip this if you're not very interested. But we're on the send email route. Click Developer Tools, F12, go to Network, do another refresh. And we see each one of these files loaded. We click one to the script.js, and we go to this server right here. We see it's loaded from nginx. Same with the style.css. If we didn't have the nginx configuration specifying to load CSS and JS files from nginx, they would have loaded from the web server directly. For one web page, for these small amount of files, not a big deal. We have a big web page with a lot of images, very large images, videos, CSS files, JS files, etc. Loading from nginx saves a lot of time. So that's why it's recommended. Real quick, nginx config, that's where we're specifying all this right here. This is what enables us to do that. Okay, going back. All right, so that's how to run the application locally. One other thing I want to show you real quick is changing from rabbitmq to redis. They both can be used very interchangeably here in this video series because this is a very simplified example. Obviously, they have their own very specific use cases where rabbitmq is preferred in certain scenarios and Redis is preferred in other scenarios. You have to make that choice based on your application requirements and your own research. So real quick switch, we're going to comment out rabbitmq, and because we have rabbitmq as a dependency for certain other containers, we just need to replace that with Redis. Just going to Control F for rabbitmq right here. I already provided you the alternative comment right below for Redis. Just continue on. Right here, this is in Celery Flower. We need to change our broker URL. Right below it, change that. Change this right here. Right here. And last one, right down here for nginx. Great. Once you have all that set, back up to the top. And then one other thing you need to do is go back to your environment file. And we just need to change our Celery broker URL right here. Comment this one out. And then uncomment the Redis one, because now we're using Redis for our message broker. Once you have that, go to your terminal, make sure you kill the other running process if you still have it running, and then just run docker-compose again, this time with Redis. Okay, once you see the task printing here, you know it's probably working fine. So we can go to our localhost again. You can just refresh the send email, and we see it's running fine. We go to Flower real fast. We see we've had 2 succeeded tasks, so we know everything's working fine. Great. So that's how we can switch from rabbitmq to Redis. Okay, that's it for this video. In the next video, we're going to walk through how to get it working on AWS now. We're going to push all of our containers, the 6 from our Docker Compose, either rabbitmq or Redis, depending on which one you want, all of them to AWS. And we're going to have it running on AWS. And we can access our application through a DNS name provided by AWS. The video's focus is very much going to be on just get it working. We're not going to walk through the security components, the networking setup to make it production ready. We're just going to get a working example. In the next video after that, we'll work on making it more production ready. But I want to give you a working example so you have something to play with before we start getting into all the details. Because that's, in my opinion, one of the worst ways to learn. Bog you down with all the details that are necessary to just get something working. I want to give you a working product so you have something to actually reference to before I start teaching you all the different stuff that goes on top of it. So with that being said, thanks for watching this video. Hope you learned a lot. Again, if anything was a little esoteric, you wanted me to go in more detail about the files, refer to the previous video. There's going to be timestamps. And if you have any questions or comments, leave them below. Be happy to respond. I'm sure someone else will in the comments will help out as well. And yeah, stay tuned for the next one. I'll see you there.